If you look at the software running the modern world, engineers constantly face a structural dilemma. You can build a massive, unified block of code, a monolith, or you can shatter that architecture into thousands of independent, buzzing servers. We see this exact same tension in human potential. You can raise a well-rounded generalist, or you can deliberately craft a hyper-specialized prodigy, like chess grandmaster Judith Polgar. The trap is scaling. A generalized foundation, in databases or education, is stable, but under massive load, a single pillar cracks. Fracturing the system into specialized parts distributes weight, but instantly introduces network latency, communication bottlenecks, and chaos. Elite engineers and educators do not accept this as a fixed rule. Instead of choosing between absolute order and specialized chaos, they bypass the trap entirely by building what we can call a modular monolith. To understand how this works, we have to look at the architectural blueprint. The bottom layer of any system expected to survive extreme pressure must be unified, simple, and entirely safe. Toyota applies this logic physically. Their safety sense collision avoidance system is not an optional luxury. It is a non-negotiable standard built into the base layer of every single trim level, acting as an absolute baseline. Ethereum establishes this same foundation digitally. At its core is the EVM, or Ethereum Virtual Machine. It acts as a single global state machine, a world computer, that strictly enforces the exact same rules for every participant, without exception. You can even see this in the NTC learning system for child development. Before introducing a child to specialized academic pressure, the system requires a broad, generalized foundation of neurophysiological play. Whether you are manufacturing cars, deploying smart contracts, or raising children, a system survives extreme future loads only if it's directly on top of that safe core is the interface layer. This is how a system physically connects its foundation to high-speed execution through strict routing and discipline. Take the physical ergonomics of playing the guitar. When a player tenses up their hand, they lose speed. Physical strain is treated as a literal bug in the system. Software architecture mimics this physical discipline through pure functional programming. This is a strict coding style that isolates unpredictable side effects, like a function accidentally modifying a variable elsewhere in the program, so the execution path remains completely clean. Elite performance is rarely achieved by pushing harder through the friction. It is achieved by architecting the system's interface to isolate and eliminate the tension entirely. Finally, we reach the extreme edges of the blueprint. This is the top layer where the system deliberately fractures into hyper-specialization to process massive scale. In modern software, a single monolithic database will eventually stall under global traffic. Engineers are forced to shift to distributed systems, splitting the workload across highly specific tools, like graph databases that map complex relationships in milliseconds. This extreme specialization has a direct mirror in elite human performance. The Polgar family proved this by raising their daughters in an intensely enclosed, carefully controlled chess environment. To reach the level of grandmaster, a child does not rely on broad, generalized intuition. They memorize and execute thousands of specific, reusable board patterns. Extreme specialization is a high-risk, high-performance engine. It should never act as the foundation of your system. It is a final gear, engaged only when the sheer weight of reality demands it. When you step back, the modular monolith blueprint is clear. You have a system that is perfectly safe at the center, highly disciplined in its routing, and infinitely complex at the edges. This structure reveals the economics of anti-fragility. Prematurely optimizing your life, your business, or your code for specialization introduces a fatal vulnerability. If the environment shifts, a rigid, specialized system shatters. The most resilient strategy is to adopt a monolith mindset. Start as a generalist. Build your automated, non-negotiable pre-collision safety systems at the base layer before you even attempt to scale. You have to resist the urge to fracture into niche expertise until the load becomes far too heavy for your generalist core to bear. True mastery is not the avoidance of friction. It is the deliberate engineering of an architecture that takes chaotic, real-world friction and safely routes it into structured fuel.